Hello everyone. So today we are going to deal with the problems that is associated with the concept called inductive effect. This is a very important concept in general organic chemistry. So sometimes we have seen some questions where it is told us to show the exact order of acidity or exact order of basicity, or sometimes the stability of some intermediate. For examples, here it is asked to explain the order of the acidity. So trichloroacetic acid, dichloroacetic acid, and monochloroacetic acid, which will be the more acidic in nature. Here again, they gave some acids like alpha haloacetic acids has been given, and it is asked that which one will be more stable, or sorry, which one will be more acidic in nature. Here, two bases are given, ammonia and dimethylamine, methylamine, and it is asked that which is more basic. Again, it's a concept of order of basicity. And here, which carbocation or which intermediate is more stable. Sometimes we can see that which carbon ion is more stable and which radicals are more stable, or show the stability order of the radicals and carbon ions or carbocation. These kind of questions are very common in IIT JEE mains or advanced or any kind of competitive examinations. So we'll see how the simple concept of inductive effect can help us to solve this kind of problem. So first we'll make the concept clear. So what is inductive effect? Now when two atoms will form a covalent bond, as they will share the electrons equally, it will be exactly in the middle of the covalent bond, right? So the bond is non-polarized or non-polar. Now if one of the atom is very electronegative than other atom, then they will pull the electron pair to it, and that's the reason that this kind of bond will get polarization. So the more electronegative get negative, the more electronegative electron will get some negative charge, and the other atom will get some positive charge. So the more electronegative atom will get the negative charge, and the other atom will get the positive charge, but in partial amount. So partial polarization, this is called. Now once this polarization happens to a molecule, what happens to the adjacent bonds? As we know, in organic system we have a chain kind of system, right? Carbon 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 chain is there. Now if we have something, this kind of pulling effect for this polarized bond, what will happen to this kind of bonds, all these bonds, what will happen there? So these bonds, how it will behave? So here you can see, as this atom, more electronegative atom, pulling the electron from this C1. So what will happen? Carbon will be, now C1 will be little bit electron deficient. So to just remove this deficiency of electron, or this delta plus character, to just neutralize this delta plus character, it will again pull the electron pair of the next bond, and it will induce another little bit polarity there. So this carbon, this will be again slightly positively charged, but that polarization is lesser than the first one. So this delta plus is more positive, delta plus is less positive. Again the same effect will happen here, where delta plus charge will be there in C3 atoms, which is even lesser than delta plus. So as a whole, if a polarization will take place in one bond, and that bond will induce polarization to adjacent bond, then it is called induction of polarization or inductive effect. As a whole, this effect is a very permanent effect. That means this effect will not depend on any kind of temporary things like reagents, external reagents, solvents, or kind of things. And as they are permanent, many kind of permanent properties of the molecules can be explained with this effect. And importantly, as we have seen, from 1 to 2 the partial positive charge on carbon atom reduces, and 2 to 3 is further reduces. You can understand the effect is reducing along the chain, means far away, as far as from the polarized bond we can consider, the effect is reducing there. So it is quickly reduces with distance from the main polarized bond, right? So this is the concept of inductive effect. Now we'll understand about two type of groups, which is showing negative inductive effect and which is showing positive inductive effect. So what is negative inductive effect? So any cases where X is more electronegative than carbon, or any group is there where the attaching atom X is more electronegative than C, then we are showing that negative inductive effect, because the electron is pulling by this electronegative atom, and as a whole, because of the polarization and induction of the polarization, the electron is moving away from the system towards that group. So that group is -I group, or that is called negative inductive effect. If the X is more electropositive than carbon or less electronegative than C, what will happen? Just inverse will happen. So as right now, and in that right now X is more electropositive, it will push electron, or carbon will pull electron, because carbon is more electronegative right now, C1. Now carbon will get some electron density on it, and this carbons, or this atom C1 atom, you can consider in nature, they are very honest. If they have some money, some electron density already there, they don't want any more money or any more electron density. So what right now he is having an electron sharing, he will tell no, I don't need. He will push towards the other atom, C2 atom, and again it will get little bit more electron density, just exactly opposite to the delta plus. Like that way, delta delta minus, it will appear the opposite to delta delta plus. And again, as this will get, this C2 will get little bit more electron density, this will push the electron to the C2, and C3 will get again some electron density, that is the delta delta minus electron density. So in general, a group which is attached to C1, if the attaching atom of the group is, or the group is overall more electronegative, then it will show the minus I effect, it will pull the electron and the effect will reduce through the carbon length. And if the X is more electropositive or less electronegative than the C1, sorry, it will push the electron to the system, that is the plus I effect, right? So this is very important, it will help us to answer many questions. Now there are some increasing order of some group for both plus I and minus I effect. So the left hand side you can see for plus I effect, and the right hand side you can see for the minus I effect, right? Now you can memorize this table or this order, but at the same time I will give you right now some idea or concept to remember. Later in next tutorials I will show you how each and every order can be explained with basic concept of general organic chemistry or chemistry, like electronegativity, electron richness and all these things, but it will take more time, so I am not including it here right now. But for the time being, you just keep in mind few points. So first, for this group you need to understand which is the attaching atoms. For example, I have a carbon atom and with this some group is attached, right? Now in this group, which atom is linking with that carbon? So the connecting upper atom is important. For example, in this group, O is the connecting atom. In carboxylate group, but carbon is the connecting atom, right? In NR3 plus group, nitrogen is the connecting atom, but in SR2 plus group, sulfur is the connecting atom. It is very important to identify these things. Now, more the electronegative of this atom, generally that group will provide the minus I effect, and more electropositive, it will provide the plus I effect. But all the cases, it is not the same. There are some questions, there are some paradox, there are something exceptions are there, but all things are within reason. There is nothing unreasoning thing, or we can't explain with reason. It is not like that. So if electron deficiency is there in that atom, then it will show minus I effect, more minus I effect. For example, you see these three groups. In these three groups, you see the central atom or connecting atom containing positive charge. This is having positive charge, right? Now that's the reason it is that electron deficiency is there in that atom, and it will show minus I group. If more electron richness is there in that group or on that particular atom, it will show plus I effect. That's why you see these two group where the negative charge is there, electron richness is there, they are in the top of this particular series. And here with the plus effect, they are in the top of this minus I series, right? That is the reason. And also we have to keep in mind, for example, keep in mind that if two atoms are same, like carbon, both the carbon, but one carbon is sp2, one carbon is sp, then sp, that s character is 50%, right? And here sp2, it is almost like 33%, right? So s character is more, means more electronegativity, because s orbital is near to the nucleus. So s character is more electronegativity, and hence more minus I effect. So this is important for same atom or having same group, or groups having same atoms where the connecting atom are same, particularly carbon. You have to see the hybridization. In that case, the more s character in hybridization, it will be more minus, it will exert more minus I effect. Example, acetylene and alkene, C triple bond C and C double bond C. You can see this one is showing higher minus I effect because it is sp hybridized, and this is showing lower minus I effect because it is sp2 hybridized, right? So are the important things. Obviously I will come with the detailed explanation which will clear your concept further and help you to solve very advanced level complicated tricky problems. Now with this concept of inductive effect, we'll explain our questions, the basic questions, the acidity order and the basicity order. So to understand the strength of the acidity, so what we'll do? To understand the strength of the acidity, we'll keep in mind that HA, if a bronzic acid, will dissociate in H plus plus A minus. A minus is the conjugate base, right? Now, the more stable the conjugate base, what will happen? That more acidic is the HA. What is the reason? Because as this will get stability, and for weak acid it is very true. Keep in mind, weak acid or sparingly soluble acid, the equilibrium will shift towards right. As the stability of this conjugate base will increase, the equilibrium will shift and it will generate more H plus, and the acidity will increase. So it's all lying in the concept where the stability of conjugate base is more or less. Got the point? Now, sorry, we'll just keep it there, HA, and we'll just keep these things. And now we'll see that trichloroacetic acid, this series we'll see. For example, we'll take just the example of chloroacetic acid. So what will happen? What will be the conjugate base here for the chloroacetic acid? So chloroacetic acid is COH. Now my conjugate base is CO minus. Now this is the anion. So how it will get stabilized? So anion are electron rich. So any electron withdrawing effect or minus I effect will be attached there. It will be stable because you can consider as electron as money. So the more it is rich, the more money it is having, it will try to buy things more. It will go to the market and it will tell, I need these things, I need these things, highly reactive. But if you will be having an electron withdrawing effect, if you reduce its money, it will be very careful. Every time it will not tell, okay, I need these things, I want to buy these things, because it has like limited money. So the minus I effect will reduce the negative charge as well as it will stabilize that anion. Okay, it's a simple concept. So in case of monochloroacetate, we have only one minus I effect, right? In case of dichloroacetate, we have two minus I effect here. In case of trichloroacetate, we have, sorry, 3 times more minus I effect than the monochloroacetate. So monochloro case, the acidity, if one, the highest acidity order, then we can understand is in case of trichloroacetate, right? So the acidity order, this will be highest. The moderate one where the 2 chlorine atom is there, this is the second highest, and least is the single chloro one, and even least is, I can tell, is the simple acetic acid where no chlorine atom is attached and no minus I effect is there to stabilize the acetate anion or conjugate base. Same concept you can apply in case of second question where the conjugate base is CO minus alpha halo conjugate base. Now the more the electronegative here the halogen atom, the more the minus I effect will be there, and the more the minus I effect is there, the more the stability will be there, right? So in case of electronegativity, fluorine is having highest electronegativity, then chlorine, and then bromine, and then iodine. So it will follow the order of electronegativity because the order of electronegativity will influence the stability of conjugate base. The stability of the conjugate base will influence the acidity of the main acid, the mother acid. So the more the electronegativity at negative atom attached with the alpha position of the ester acid group here, acetate group here, the more the stable it will be the conjugate base, and the more the acidity for the main acid, right? Now the basicity order for ammonia and methylamine. So we can consider it in a 2 way. One is like Lewis concept. So this is the NH3 and this is the RNH2. So in both the cases everything is same, but here we have a methyl group, so we can write it, for example, we can write it as a methyl group. Now methyl group is having more plus I effect than hydrogen. As methyl group is having more plus I effect, it will increase the electron density on nitrogen, and as the electron density on nitrogen is more here, so this is more donatable than this, because as I told, they are very honest, the atoms are very honest. If already they will be having more electron density than other, so there, if they are having some lone pairs or bond pairs, they will try to push it away from them. Here the nitrogen is trying to push away the lone pair. Got it very clearly? Now this same explanations or same things we can explain in concept of conjugate acid and base also. There also it will explain in the same way. We'll learn both here. Like here I told, acid will give conjugate base once dissociate. Similarly, if I have a base and if I treat it with some acid, it will give a conjugate acid. For example, if I have a base like RNH2 and if I treat with acid, it will provide RNH3 plus. Okay, that is a conjugate acid. Now similarly, more stable the conjugate acid, more basic the base, as in case of acid. So here what is happening, in case of ammonia, my conjugate base is this one, and in case of RNH2, my conjugate RNH2, or methyl NH2, my conjugate base is this one, this methyl NH2. Right now, which one is more stable? Because of the plus I effect, this one is more stable. So the conjugate base of NH2, that is MENH3 plus, is more stable. Right? Sorry, this is more stable, right? So as it is more stable, this one is more basic. So this is the way, with the help of Bronsted acid base and all this concept, we can explain the acidity and basicity. Now this question, this you can answer yourself. So carbocation, more positive carbocation is more reactive. The positivity will reduce, it is less reactive. For example, I told you no, that if electron richness is there, if electron is money, if electron richness is there, he's a very rich person, he want to buy things from markets, very reactive. Again, if he doesn't have any money, he's very poor person, he want to snatch things from the market, from everyone. Again, he is very reactive, but in a negative way, in the opposite way of the anion concept. The positive concept is the opposite way of the negative concept, right? So here also, the electron deficiency or positiveness more, the reactivity is more. Electron deficiency is more, the reactivity is more. So if we can reduce this electron deficiency or positiveness with some plus I effect, the reactivity will reduce, because it will stabilize. So if one methyl is there, it will give little bit electron to it, it will tell, okay, calm down, I'm giving you some money. If two are there, two of them will give some plus I effect, because of the plus I effect will give some electron push to this carbocation. They will tell, okay, we both are there, so don't worry, we'll provide some money to you. And when there are three methyl group, these three methyl groups, they will tell, why you are so anxious, why you are so worried, we three are there, we are giving our some money, and it will be effective enough to stabilize you, or to make you little bit rich, or to reduce your poverty. So stability will increase with plus I effect, right? Now you can order it. This is the most stable, this is the medium stable, and this is the least stable. Got the point? So this is how inductive effect will help us to explain these questions. Now before leaving, I will give you three questions to think. So first one, in which case the methyl is the plus I, will show the plus I effect. Just check the attaching atom, find the electronegativity and electropositivity with respect to the carbon, and get the answer. Think about it. Which is the more basic here? MENH2 and aniline. The same concept what I gave you the example with ammonia and MENH2. Here also you just think about the availability of the lone pair with respect to the plus I or minus I effect of methyl or phenyl group. Just think about the hybridization of the attaching carbon, that also will help here. Third question, show the order of acidity for this kind of acid where the position of the chlorine change. Again, this answer can be this question can be answered with the help of stability of conjugate base. The more the minus I effect, the more the stable the conjugate base. Now you have to understand that in which case the minus I effect will be more. Here the proximity of the chlorine is important. I told you how the inductive effect is is changing with the length of carbon chain. You have to keep that concept in mind and answer these things. So hope with all these things you are very clear with this inductive effect. Think about all these questions and you will definitely enjoy that part, and your concept and basics will be very, very solid. Hope to see you again. Goodbye.